Assalamualaikum and good morning. My name is Muhammad Ifran bin Jumhairi and my matrix number is 14 DKM21F11024. Today I will like to present about a steam power plant system. For introduction, a steam power plant works by using a boiler to heat water until it turns into steam. The steam is then used to turn a turbine, which is connected to a generator. The generator converts the mechanical energy from the turbine to electrical energy. Heat the steam then the steam is then condensed back into the water and turn the boiler to be heat again. The process is called a Rankine cycle. A Rankine cycle is or Rankine vapor cycle is a process widely used by power plants such as coal-fired power plant or nuclear reactor. In this mechanism, a fuel is used to produce heat with a boiler, converting water into steam, which then expands through a turbine, producing a useful work. The equipment of the steam power plant is the first is boiler. A boiler is a device in which water is converted into steam by utilizing the heat energy of coal combustion. The second is boiler furnace. A boiler furnace is a chamber in which coal is burned to liberate the heat energy. The boiler furnace provides support and enclosure for the combustion equipment. The third is superheater. A superheater is a device that which superheat the steam, etc. It increases the temperature of steam above boiling point of water. The use of the superheated steam increase the overall efficiency of the terminal power plant. The fourth is eco-minister. The eco-minister is a device which increases the temperature of feed water by driving heat from the fuel gas. It consists of the large number of costly spaced parallel steel tubes connected by hardened and drum. For the fifth, for the fifth is what air preheater. Air preheater is a device which extends heat from the flue gas and give it to the air being supplied to the furnace of the combustion of coal. This increases the temperature of the furnace and hence increase the terminal efficiency of the power plant. The sixth is condenser. The condenser is a device which condenses the exhaust steam to the turbine. For the seventh is prime mover. Prime mover is in the context of the terminal power plant. The prime mover is a device which converts the steam energy into the mechanical energy. The eighth is alternator. The alternator is an electrical device which converts the mechanical energy of the turbine into electrical energy. The alternator is connected to the turbine and convert the mechanical energy to electrical energy. For the third is theory about the steam power plant. A steam turbine is a rotary heat engine that converts terminal energy content in the steam to mechanical energy or electrical energy. From the for the thermodynamic point of view, a performance of steam turbine can be derived from the Rankine cycle theory and idealized thermodynamic cycle of the consistent pressure heat engine that convert part of the heat into mechanical work.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hazim Abail. My matric number is 14DKM21F100F. So today I want to tell you about historical of steam plant processing. In 1698, an English military engineer and inventor developed the first form of the steam engine using the concept found in the pressure cooker. Thomas Savery had been attempting to resolve the problem of water building up in a coal mine. His steam-powered invention used a closed receptacle to produce steam under pressure. Cold water was added, create a vacuum to suck the way of the mine. Okay, so this is a figure for Thomas Newcomb's steam engine. In 1764, James Watt was asked to repair Newcomb's steam engine. As he worked on the interiors of the machine, it concluded the design was flawed and inefficient. Inspired by his finding, was decided to take a Newcomb principle concept and improve on them using his understanding of machine. Though Newcomb model was sufficient for its purpose, it allowed steam to escape, which decreased the power of the engine. What found a way to harness the escaping steam by adding a separate condensing chamber and patented his design as a separate new invention. What enhancement made the steam engine available to more industry than mining and able to serve multiple functions. Soon after its adding mining, cotton mine and another industry rise in corporate steam power in their operation. Explanation used in industry. So, in the chemical plant, steam is widely used in the process for heating purpose at variable pressure, usually from a saturate low pressure to a superheat medium to high pressure boiler and used to generate the power. The enthalpy drop from boiler pressure to a process pressure is done in steam turbine generate of a PRV. A plant can be benefit by generating its electric by installing a steam turbine generator. The size of the turbine or a boiler depends on the plant heating and electric load. Proper application engineering can help to reach the high overall efficiency by optimizing the boiler and the turbine size. B. So this is the advantage or the advantages of system. Advantage. Fuel use is cheaper. They can respond quickly with change in the load of the plant. Space required is less compared to hydro power plant. A portion of steam can be used as process steam for various industries. The disadvantages: operation and maintenance cost is high. Time need for erection of plant is higher before it is put to operation. Large quantity of water is needed.
My name is Azib Ikhwan bin Ahmad Nizal. My matrix number is 14DKM21F1008. 5. Application in industrial. Select one industry and elaborate. A. Name of industry. One of the industry that use steam power plant is oil and gas industry. This industry has dozens of operation that use of a steam plants. Steam, hot water and electricity are used for heating hydrocarbon mixture in separation columns, preheating crude oil, heating piping system, and in the distillation process such as fractional distillation. Here a elaboration on their application. Heating and cooking. Oil and gas fuel are commonly used for residential and commercial heating purpose. They provide heat for building and home through furnace, boiler and space heater. Additionally, natural gas is widely used for cooking in household and commercial kitchen. Petrochemical industry. The petrochemical industry relies heavily on oil and gas and as feedstock. These hydrocarbons are transformed through process like cracking, refining and polymerization to produce a wide range of petrochemical products include plastic, synthetic fiber, rubber, solvent and example of company. One of the example in is Petronas, short from Petroleum Nasional Berhad is a Malaysian oil and gas company that was founded in 1974. This is fully owned by a Malaysian government and operate as a integrated oil and gas company involved in various aspects of the industry, include exploration, production, refining, marketing and distribution of petroleum products. Petronas is involved upstream activities such as oil and gas exploration, development and production. It's explore for hydrocarbon reserve and operate both onshore and offshore field, include deep water project. Petronas has significant upstream asset in Malaysia as well as in other countries. Relate to plant engineering technology application. Explain in technical word, layout, picture, video and technical diagram. Certainly, plant engineering technology is widely used by the oil and gas sector for the exploration, extraction, processing, and distribution of petroleum product. Here is a description of the application in the oil and gas industry utilizing technical jargon, layout, diagram, and image. Offshore drilling platform. Oil and gas deposit are extract from the seabed using offshore drilling platform. They include production facility, support system, and drilling rig. Here is the streamlined blueprint for an offshore drilling rig. Refinery process. Refineries are placing where crude oil is transformed into different petroleum goods include jet fuel, diesel, and petrol. The distillation, crack, reforming, and other refinery steps are used in the process. Here is a streamlined refinery process flow diagram. Pipeline transportation. Oil and gas are effectively transported across great distance via pipeline for the purpose of ensuring dependable and secure conveyance. They need pumping station, valve, and motoring system. Check out the illustration of a pipe architecture.
Hi, my name is Muhammad Shazwan bin Muhammad Shahrom. Number matrix 14DKM21F1010. I will continue number 6, data. This is the data about system power plant that get from Ibrahim Lindsay, March 8, Russell in SRG 2007. Steam power plants are widely analyzed, touch out the work of electricity and generation, and coal is often used to fuel these plants. Although the world existing coal reserve will be sufficient for about 2 centuries, the technology largely used today to produce electricity from coal causes significant negative environmental impact. Of the analysis techniques available, exergy analysis is perhaps the most important because it is a useful, convenient, and straightforward method for assessing and improving thermal generation stations. The insights gained with exergy analysis into plant performance are informative. Number 7. Processing flow. The processing flow of a steam power plant involves a series of interconnected processes that convert thermal energy from the combustion of fuel into electrical energy. Here a step-by-step explanation of the typical processing flow in a steam power plant. Number 1. Fuel combustion. The process begins with the combustion of a fuel source, such as coal, natural gas, or biomass. The fuel is burned in a boiler, where it releases thermal energy in the form of heat. Number 2. Boiler and steam generation. The heat generated from fuel combustion is transferred to water in the boiler. The water is heated, and as it reaches high temperature and pressure, it is transformed into steam. The boiler consists of tube or pipe immersed in the water, surrounded by hot gas from the fuel combustion. Number 3. Steam turbine. The high pressure and high temperature steam produced in the boiler is directed to a steam turbine. The steam enters the turbine at a high velocity and pressure, causing the turbine blade to rotate. Number 4. Mechanical energy conversion. As the steam passes touch the turbine blade, it expands, losing pressure and temperature. This expansion of surface turbine extracts the thermal energy and converts it into mechanical energy. The rotating turbine shaft in generator touch a coupling, which allows the mechanical energy to be converted into electrical energy. The processing flow represents the core operation of a steam power plant. However, it is important to note the specific plant configuration and additional auxiliary systems such as air and flue gas handling and control system may vary depending on the plant design and requirement. This picture is a processing flow for steam power plant. Number 8. Conclusion. As a stable and effective way of turning thermal energy into electrical power, steam power plants have been a mainstay of electricity generation for many years. These power plants use steam as a working fluid to power turbines and produce electricity. Operating according to the basic laws of thermodynamics, a little amount of ingenuity and engineering can boost the steam power plant efficiency. Even if the result falls short of your expectation, you will still be able to make system improvement. Systems in steam power plant have an essential function in a number of businesses, including the palm oil industry, for power generation, process, and other industrial applications. This system offers dependable and efficient energy generation.